All right, I don't got minutes to spare here. Let's jump straight in. When you're multiplying radicals, the numbers that are inside multiply together, the numbers that are outside multiply together. That's a little bit foolish because we just built up something that we're going to tear back down. The 3 times 15 becomes 3 times 3 times 5. 3 comes out of the radical and joins the 40, becomes 120. Square root 5 is what's left. There's a harder way and a shorter way to do number 2. Here's the longer way. Multiply by the square root of 21 over the square root of 21. You get 30 times 21 is 2 times 3 times 5, and then 21 is 3 times 7. Square root of 21 times the square root of 21 is 21. What comes out of this? If 3 comes out, the 2, the 5, the 7 stay in. That becomes a 70. And then 3 and the 21 reduce, and we get square root of 70 over 7. Or we could have realized that 30 over 21, 3 goes into both of those 10 and 7 times. That reduces the square root of 10 over the square root of 7. Now we just multiply by the square root of 7 over the square root of 7, and we get the same answer, but a whole lot quicker and easier. On number 3, we're going to, number 3 I didn't do. Time out. Here we go. We're going to square 10 square root 6. We're going to square the 10, which is 100. We're going to square the square root 6, which is 6. Multiply those together, we get 600. The geometric mean is the number that's where the means are the same. 9 over x equals x over 50 in this case. Multiply the 9 times 50 together. That's 3 times 3 times 2 times 5 times 5. A 3 and a 5 come out. The 2 stays in, and we get 15 square root of 2. On number 5, to determine what type of triangle you get from 3 lengths, you first need to make sure you can make a triangle. 10 plus 14 is greater than 17. Yep, we can make a triangle. So, what type of triangle is it? Now we do the Pythagorean theorem. 10 squared plus 14 squared. How does that compare to 17 squared? Well, 296 is greater than 289. So the c squared is smaller. That's acute. Number 6. Square root 2 is 1 point something. Square root of 31 is 5 point something. When you add those together, you'll get something greater than 6. So yeah, we got a triangle. Square root of 2 squared plus the square root of 31 squared has it compared to 6 squared. Square root of 2 squared is 2. Square root of 31 is 31. So that's 33 is less than 36. The 36 is bigger. It's acute. On number 7, don't just jump into doing it. I put the bigger one in the middle. Therefore, C is your 109. We do get a triangle out of it. So 60 squared plus 91 squared, how does it compare to 109 squared? They are equal. Turns out that's a right triangle. And number 8, is 10 plus 12 more than 25? The answer is no, it is not. That is not a triangle at all. Moving on. The diagonals of a rhombus. Well, what's a rhombus? It's a quadrilateral with all those congruent sides. The diagonals, of course, make a right angle there in the middle because they're perpendicular. What happens to that 12, the length of the diagonal? So, well, it becomes 6 and 6. The other one becomes 8 and 8. Now, I have these right triangles where x is the hypotenuse, and x is also a side of that rhombus from which we're trying to find the perimeter. 6 squared plus 8 squared equals x squared. 10 is what you get when you do that, guys. And there's 4 of those 10s around that rhombus, so 4 times 10 is 40. If the perimeter of a square is 11, then each of those sides is, the perimeter is 44, then each of the sides is 11. The diagonal, because a square is a rhombus and a rectangle, it creates this 45, 45, 90 triangles. So that's a 45, 45, 90 triangle. I'm going to multiply the leg times the square root of 2 because x is the hypotenuse in this case of that 45, 45, 90 triangle. 11 square root of 2 is my answer. The length and width of a rectangle are 6 and 10. Then the length of the diagonal is x. Hopefully you see the right triangle here. X is the hypotenuse. 6 squared plus 10 squared equals x squared. Solve, solve, solve. We get 2 square root 34 for our answer here. If one side of an equilateral triangle is 30, that means all the sides of the equilateral triangle is 30. The length of the altitude is x. I think we know something about the angle measures as well. It's 60 degrees here. The altitude chops this 60 degrees in half. That's a 30, 60, 90 triangle. The altitude also chops this 30 in half, so that's 15. 15 is the short leg. X is the long leg. So 15 times the square root of 3 is the length of that altitude. So katoa down here at the bottom. The cosine of D didn't happen. I'm not sure what's going on there. Let's see if it may pop up here in a second. The tangent of K, from the perspective of K, 2 is opposite. The square root of 11 is adjacent. 2 divided by the square root of 11 is, we have to simplify. Square root of 11 over the square root of 11 becomes 2 square root of 11 over 11. Here it comes. The cosine of D. Got out of order there. Cosine is adjacent over hypotenuse. That's adjacent to angle D is 2. The hypotenuse is the square root of 15. So 2 divided by the square root of 15. I again have to do the square root of 15 over the square root of 15 and do some simplifying. These guys are a little ugly, but it's a simple process once you get to it. The sine of D is the opposite side, square root of 11, divided by the hypotenuse, square root of 15. So that's square root of 165 divided by 15. 165, those factors are 11, 3, and 5. Nothing's going to come out of that. It's simplified like that. On this guy over here, to do sine, cosine, and tangent, I'm probably going to need to figure out what this side is over here. So let's go do it. Let's call it an x and go use the Pythagorean theorem. 50 is the hypotenuse. When you solve, you will get 14, or at least you better get 14. You should get 14. So the cosine of r, from the perspective of r, 48 is adjacent, 50 is the hypotenuse. That should reduce, and does, down to 24 over 25. The sine of c is the opposite, 48, divided by the 50 hypotenuse. Remarkably, it's the same thing. Hopefully you understand why. The tangent of r is the opposite. That's the 14 we solved for, divided by 48. That's a good thing we solved for it, because we needed it. It's 7 over 24. All right, moving on. Find the value of the simplest radical form. All right, what type of triangle is this? I see these angles are congruent. If those angles are congruent, then I think they have to be, what, 45 degrees? Isn't that right? Yep. So this is a 45, 45, 90 triangle. Y and the square root of 6 are the legs. X is the hypotenuse. So if I know that one leg is square root of 6, the other leg in a 45, 45, 90 is also square root of 6. To find the hypotenuse, we're going to multiply by the square root of 2. So the square root of 6 times the square root of 2 is the square root of 12. Simplify that sucker, we get 2 square root 3. Number 20 is also a 45, 45, 90 triangle because we see the 45 degrees. The magic number in the 45, 45, 90 is the square root of 2, of course. We're going to take the hypotenuse, which is 22, and divide by the square root of 2. Simplify that, we end up with 11 square root 2 for our answer. Number 21 is not a 30, 60, 90 triangle of 45, 45, 90 because I don't see those angle measures anywhere. But I do see two sides given and a third unknown. That's when we'll use the Pythagorean theorem. X squared plus the square root of 13 squared is 7 squared. When we square, subtract, we get x squared equals 36. X ends up equaling 6. There was a mistake on your copy of this. This side right here needs to be 25 in order for us to continue with this. Because that altitude, if it's not isosceles, will not split that 48 in half into 24, which we need this to be. At isosceles triangle, though, that altitude will always split this other side in half and then make a right triangle, like so. Now we can go x squared plus 24 squared equals 25 squared. When you solve that, you should end up getting 7. Oh, I see that number, 60 degrees right there. That's 60 degrees. We're going to use short leg, long leg, and hypotenuse. Which ones are the short leg, the long leg, and the hypotenuse? Let's see. You got the 33 is the long leg that's given. We will always go from the long leg to the short leg. Never go from the long leg straight to the hypotenuse. But to do so, we divide by the square root of 3, bigger to smaller, divide. Magic numbers are square root of 3. We got a little simplifying to do. We end up getting 11 square root 3 for y. That's 11 square root 3. I don't know why that says, hold on, 3 square root 3. Yeah, I had a typo there. Probably not my only mistake on this thing. So that was 11 square root 3 multiplied by 2. We get 11 square root of 3 times 2, which is 22 square root of 3. All right, number 24. We don't have 30 degrees or 60 degrees or 45 degrees, but I do have two sides, missing a third. Pythagorean theorem. Y squared plus the square root of 13 squared equals 36. Y equals the square root of 23, which does not simplify. That is your answer. 25. When you see a half of a rectangle, those two right angles there, hopefully by now you know we're going to make a right triangle with that rectangle. The properties of the rectangle will help us. 13 and 13 come across, 24 and 24 get up there. Now, this side, this green side right here isn't 20. This whole thing is 20, but that was 13, so what is left? Yep, it's 7. So now we'll go 7 squared plus 24 squared equals what squared? And we end up getting 25. 26 is the Pythagorean theorem. No angle measure is given. Two sides are given. 4 squared plus 6 squared is x squared. 2 square root 15 is what we get. I do see 30 degrees here, so therefore we will use the short leg, long leg hypotenuse on the 30, 60, 90 triangle. What was given was 44, the hypotenuse. 44 divided by 2 gets us the short leg, 11. Oh my goodness, no. Right, what I said was 44 divided by 2 is 22. Of course, that's what I said. Now that we have the short leg is 22, we multiply by the square root of 3 to get the long leg. 22 times the square root of 3 is 22 square root 3, which is that answer. Whew, okay. Oh my goodness, I see two triangles in one. Buy one, get one free. Oh my goodness, I see 30 degrees here. I see 45 degrees here. I see variables here, no side lengths given. Oh, I see a side over here. We need to first solve this 30, 60, 90 triangle first, so we can find that missing side. According to that green triangle, square root 2 is the short leg. We need the long leg to help us with the other triangle. How do you go from the short leg to the long leg? That's right, we multiply by the square root of 2, so we get the square root of 6 for the short leg, or for that long leg. Okay? Now, let's turn our attention to the 45, 45, 90 triangle. We have the legs and the hypotenuse. The legs are square root of 6 and x, so x equals square root of 6. Y is the hypotenuse, so we will multiply by the square root of 2. We end up getting 2 square root 3. That feels familiar. Number 29, I got a right angle here. I got an altitude with a right angle there. I got 3 right triangles. I got the big one and then the 2 smaller ones. That's when we do the geometric mean. It's the geometric mean with respect to the pieces of the hypotenuse. In this case, the altitude here shares a triangle with 6 and with 24. It's the geometric mean between 6 and 24. We don't use the 30 for the altitude. We would use 30 if we needed to find that leg over there. When we simplify this guy, we end up getting 12. Isn't that clever? All right. I also see another buy one, get one free, but I see no angle measures, no 30, 60, 90, or 45, 45, 90. But I need to solve for this missing side. I'll use the triangle on the left first. 6 squared plus something squared, I'll call it y, equals x squared. That y now is going to equal 8. Okay, that's great. So yeah, we get that this side here is 8. Now we can solve this other right triangle. 18 squared plus 15 squared equals x squared. I wish you all had learned the triples. Gosh, that would make your life so much better right now. That answer would be 17. Not your fault. Not mine either. All right, number 31. We have angle measures. That's not 30 or 60 or 45. I only have one side given. When the question is about two sides and an angle, that's when we will use so, ka, toa. In this case, from the perspective of the angle, I'm given the hypotenuse 23 and a is the adjacent. That's cosine. The cosine of 25 equals a over 23. Make that a proportion, and then we will either cross multiply or switch the extremes. In this case, a times 1 gets a, so we cross multiply, get our answer like so. Next question, similar in the sense I got a side, an angle, and then x is another side. I'm going to use sine, cosine, and tangent. From the perspective of that 36 degrees, x is the opposite, 7 is the adjacent. That's tangent, folks. So we write the tangent of 36 equals the opposite x over the adjacent 7. Make that a proportion. we cross multiply to get x times 1, 7 times the tangent of 36. Every time when we do this, when x is on the numerator, cross multiplying will get us x by itself. Unlike, I think the next one, according to 72 degrees, 63 is the opposite, x is the hypotenuse, that's sine. The sine of 72 equals 63 over x. In this case, x is on the denominator. When your variable's on the denominator, when you're solving a sine, cosine, and tangent like this, switch those extremes and becomes x over 1 equals 63 divided by the sine of 72. Type that into your calculator, you'll get your answer, 66.2. 34. Dang, give me all three sides. I'm missing the angle. So what do we do to solve for the angle? We'll use the arc sine, the arc cosine, the arc tangent. When it's given all three sides, from the perspective of our angle, take your pick. I can use the sine, I can use the cosine, I can use the tangent. I got them all. If you want to type all three of those in your calculator, you're going to get the same answer. It's 67.4. It did not matter which pairs of sides you used. Number 35, from the perspective of my angle, 100 is opposite, n is adjacent, that's tangent. The tangent of 49 equals 100 over n. To get n over the 1, cross multiplying doesn't help me. I want to switch those extremes. N over 1 equals 100 divided by tangent of 49. Type that into your calculator. A bit of a typo here. This should be a right angle and a right angle. Otherwise, no way to solve it. But I need to solve this missing side over here on the right. I see a 45, 45, 90 on the left. Hypotenuse to short leg, divide by square root 2. 20 square root 2 is what we're going to get. Now I can use, from the perspective of 37, opposite and hypotenuse, which is sine. Be careful typing this into your calculators. Make sure you have parentheses around your 20 square root 2, or space it out correctly, because it's easy to not get 47.0 in that case. All right, I see a right angle and a right triangle with an altitude. That's the geometric mean deal again. We will use the parts of the hypotenuse, 8 and 2, and the entire hypotenuse, 10, to solve for x, the leg of the big triangle, y, the altitude of the big triangle, and z, the other leg. X shares a triangle with 8 and with 10, the big triangle, so it's the geometric mean between 8 and 10. That's 4 square root 5. Y shares its triangles, the little ones, with 8 and 2. When you solve this, we'll get 4 for y. And z shares its triangle with 10 and 2, so z squared equals the square root of it equals 20. 2 square root 5, that's what we get for 25. 38, where am I? Yeah, 38. To solve for y, I know two angles within that triangle. We knew that, that's 66, no problem. From the perspective of 24, 32 is opposite, z is hypotenuse, x is adjacent. I just got to do two things. I got to say the sine of 22 equals 32 over z, and I need to say the tangent of 24 equals 32 over x. Switch the extremes on both those guys, type them into your calculators, we'll get our answers. This word problem, picture problem, it's a right triangle thing, y'all. The height of the tree is x, the angle is 53, the shadow length on the ground is 50. That's tangent, opposite, and adjacent. It's the same, really, as what we just did. Not that different at all. That will not show up on your test in 2020. Corona. The boy on a cruise ship is standing on top of a deck. There he is. He's 48 feet tall, spots a whale out there in the sea. The angle of depression here is 7 degrees. The angle of depression will also show up in the triangle right here at 7 degrees. How far is the boat away? From the perspective of my 7 degrees, I'll use tangent. And no, that won't be on your 2020 coronavirus test either. But that's how it would work. All right, hopefully that was helpful. Let me know what questions you have. Okay, bye.